Some of you have already seen my snowplow vehicle that I built from scratch. Even though it works pretty well by now, there's still a lot of room for improvement. And since it's still winter outside, I need to keep it functional. So I have a big upgrade in my mind. But before I start changing anything on the vehicle itself, there are a few things I need to test first. And when I say upgrade, I mean a big one. In fact, this change is so big that once I start, there will be no going back. So keep watching. Right now I'm using two brushed motors with 500 watts each. And honestly, they have been a pain ever since I started using this vehicle. Mostly because of all the EMI problems they caused and everything that came with it. For example, broken locking screws such as these, broken locking pins in the gears, and the worst damage so far, a broken axle shaft. So the idea is to replace these brushed motors with brushless ones, such as these. So these kinds of motors are used in drones and many other applications. This particular one is a 1 kilowatt motor with a maximum speed of 3700 RPM and a torque of 2.5 Newton meters. So compared to my current motors, which are way bigger, that's about 30% more torque and 23% more speed. That also means the gear ratios need to be completely redesigned. So with the current setup, the vehicle has a theoretical speed of 11 kilometers an hour. I actually haven't tested it yet because the remote is still limited to, I keep it limited to 35% of throttle. I really should test the speed sometime. But of course, I can't use this motor directly in the vehicle. I need a gearbox to reduce the speed and increase the torque. For that, I'm going to use a planetary gearbox, based on the Open Torque project by Gabrael Levine. So the gearbox itself has a reduction ratio of 8. So speed and torque are strongly connected and they depend a lot on the gear ratios. If I only use this ratio of 8, the vehicle would have a theoretical top speed of almost 30. That's insane. And a torque of about 20 Newton meters per wheel or per side of the vehicle. That's not much. Because right now I'm having around 33 Newton meters per wheel or per side. So going down to 20 is a bit low, especially if we also consider losses. Because all these numbers are with 100% efficiency. But there is no 100% efficiency. There's always losses. So for now, I'm assuming about 80% of efficiency, and I'll explain why later. So luckily, the power has to go from the gearbox to the axle shaft. By using different sprocket sizes, I can reduce the speed even more and increase the torque again. So I haven't decided on the final ratio yet, but with realistic sprocket sizes, I could get another factor of about 1.36. That will give me a total ratio of about 10.9, which means a theoretical top speed of almost 22 kilometers an hour and about 27 Newton meter per wheel. 22 kilometers an hour is still a lot. To be honest, 22 kilometers an hour would be insane for that thing. But like I said, this is all still very theoretical and doesn't include losses. So the ratio is not final yet. Still have to think about that. Besides, what would you choose? So would you choose higher torque or higher top speed? Let me know in the comments down below what you would go for. But there's something very important to keep in mind. I can't just increase the torque as much as possible because the planetary gearbox and some of the belt sprockets will be 3D printed. So I will use a high strength material like PA12 with carbon fiber for the critical parts, but the stress on these components will still be extreme. And there's another problem with this material, which I'll show you in a moment. And there's also one more upgrade that comes with the motor change. I want to switch from chains to belts. but compared to the motors, that's a smaller topic. So let's get to printing. I tried to print one of the planetary gears with PA12CF, and the result was not great. As you can see, there is warping on the underside of the gear. Since these gears are very critical, they need to be printed perfectly. So my first idea was that PA12 needs higher temperatures, so I increased the print chamber temperature to 60 degrees Celsius, but that didn't fix it. So I stopped the print of the second gear. But then I noticed something. On both gears, the warping clearly starts at the first layer. No? And it really only affects the first, let's say, 20 layers. So about 3.5 millimeters from the bottom. Above that, the gear looks almost perfect if you compare it. So I came up with an idea. I designed a thin ring on the underside, 0.2 millimeter thick and 10 millimeters of height. Honestly, 5 millimeter would probably have been enough, but I felt generous. Then I turned on supports on the slicer. Now, if warping happens, it should only affect the support structure and not the actual gear. That was the thinking. And the final result shows that it kind of works. There's still some deformation on the outer layer, but I think it's good enough to test. So for now, I'll keep it like this and print the other two. So with that, let's print the rest of the parts for the gearbox. And done. Well, luckily for you, you didn't have to wait as long as I had to for the printer. So the parts are a mix of PLA and PA12CF. And here's the problem I mentioned earlier. PA12 with carbon fiber might be too abrasive for the gears actually. It already feels much rougher than PLA. If the gearbox survives for some time, we'll see how the gears look and how they wear. I also made a few changes to the original Open Torque project design. First, and the biggest change, I added axial bearings for each planetary gear on both sides. Normal bearings can take some axial load too, but since these are helical gears, axial forces will be quite strong compared to straight gears. This is just a precaution. Maybe it's not even necessary, but better safe than sorry. Second, I changed the geometry for the big bearing of Planet Carrier A, because the original bearing is extremely expensive. Around 200 euros per piece. I don't want to pay that. So I redesigned it slightly and looked for another bearing, and voila, I think it's at 8 to 10 euros. It's also a different type of bearing than original, but that'll do for now. Third, I modified the sun gear. Now, a pin rests inside a ball bearing in Planet Carrier A just to help take some of the load and hopefully increase the lifetime of the sun gear a little bit. Well, I don't want to spoil anything, but my guess is that the sun gear will be the weak point of the system. It sits in between the motor and the 3 planetary gears. So the load is split between the 3 planets and the ring gear. But the sun gear takes it all. So everything coming from the motor is going onto the sun gear. So the weak point will be somewhere here. And since this is a 3D printed part, the weakest point is probably the layer bonding here where the tooth starts. So for the sun gear as well, to avoid warping on the sun gear, I used the same trick as before. I printed it this way with supports. So because the contact surface of the pin was very small, I printed it upside down and let the slicer generate supports. And it came out without any warping. But honestly, I don't really know yet how strong this part will be. The main problem will be torsional shear. So Matt Denton actually tested this gearbox design with different materials. I'll link his video below. Definitely check it out after this video. So he measured an efficiency of about 80%, which sounds realistic to me. The real value will depend a lot on the surface finish of the gears, the material, obviously, and maybe lubrication. So based on Matt's results, PA12 might not be the best choice because of the weak layer bonding. I also printed the gears in PLA, which feels much smoother. If needed, I'll swap them later, but that's for another video. Fourth, I added some mounting features for the ESC. Everything can be mounted together nicely. All right, all the inserts are in. Let's start the assembly. The final question is, can this 3D printed gearbox survive the forces of a 130 kilogram vehicle? But before I rebuild the vehicle, winter here in Bavaria needs to end first. Until then, yeah, I can test the gearbox and try to break it. Or maybe not. So I'll make a video where I stress test the gearbox and then we'll see if it's strong enough for my vehicle. Thanks for watching. If you liked the video, hit the like button and consider subscribing. This helps me. In the next video, I'm going to do some test runs and see how this gearbox really performs. Bye!